we'll be observing protocol from now. So if you have any questions, just raise your hands when it's due time. I'll call on you for questions. So everyone, you're welcome to this class. As usual, this is brought to you. This is brought to you by KodeCamp, and at KodeCamp, we're looking at building the skill economy. So this is a sponsored program. This is straight from KodeCamp, and we've had about 6 classes. So this is the 7th class. This is our 4th week, the 7th class of the NodeJS intermediate class, and we've looked at various key concepts, and they are streamed live to YouTube. So in case you've missed any of the classes, you can go over to YouTube to catch up on everything. And as a matter of fact, everything that we've brought to you has been salient, has been important. There are concepts that you cannot afford to be lacking in. Okay, there are concepts you cannot afford to be lacking in. So if you've missed any of the classes, please go ahead, go back after this class to go over those concepts thoroughly, because you will need them. Okay, I assure you, you will need them. And when you find the use for them, you will really, really appreciate what we've been doing. So today we'll be looking at database management systems, and I'm hoping this will be probably the last class where we have so much of theory, and from next class we're moving into raw code and lots of stuff. But we need to understand some very key concepts, and that's the purpose of today's class, ironing certain things. So when we talk about database management systems, we'll be looking at, okay, I didn't put this together. But here, okay. So my name is Benjamin. I'm a software developer, experienced with the MERN full stack and the .NET full stack. You can reach me at Slack, at our KodeCamp workspace at Slack. My username is Aerosoft, and I'm not alone on this. Okay, I have here a mentor, Prosper, and he's experienced with Node.js, MongoDB, Express.js, and TypeScript. He's a very solid hand. So if you have any issues technical, you could always reach out to him, and he's available to put you through. So you can reach out to us at on the Slack workspace, okay, KodeCamp Slack workspace. You can reach out to Prosper.js, and we'll be able to see how to put you through. So today we're looking at database management system, DBMS. And what exactly is a database management system? These are basically software systems used to store, retrieve, and run queries on the database. Okay, so they are used to store, retrieve, and run queries on data. Now, a database management system serves as an interface between an end user and a database. And when we say end user, we might not be talking about the client, we might not be talking about the person on the browser, we might be talking about an end user, which could be an application. Okay, so when you see the word end user, don't jump straight into considering a person, because people don't usually talk to the database directly. They do so using applications, and applications will be more of your client or your server-side program, your API, talking to the database. So it serves as an interface between an end user and the database, and it allows users to create, read, update, and delete data in the database. Now, talking about the types of databases, there are so many different types of databases. We have the hierarchical, okay, the hierarchical databases, and this talking about databases that are more like, they're set up more like tree structures. Okay, so they're set up in hierarchies. Then you have your network database, and this is more of a showing like a network of interconnected data. Okay, so there, when you see network, you might be thinking about network in terms of internet connection, but yeah, it's talking about like network in terms of how the data is connected from one to the other. So that's network databases. Then we have relational databases, which generally are one of the most common types of database management systems. So we have relational databases, talking about things like SQL, talking about MySQL, MariaDB, and other sorts, SQLites, MS SQL. So you have different types of relational databases. We'll look at it in details. We have object-oriented databases, and this here is talking about databases that have to do with, storing more of like object concepts. You have there that you're not just storing things like data, but you can also be storing methods. So object-oriented databases, they are pretty much very difficult to set up because you're having like advanced concept like methods stored in the database, no longer just you having an object or a method. And you know how the way we talk about what OOP is like. So imagine a database that has that kind of functionalities as you get from an OOP. That's what you have in object-oriented databases. Then you have graph databases. So graph databases, they are more of like it looks somewhat like hierarchical databases. You have like like more of an interconnected link of how data is stored. Okay, so there's so much of interconnection there. And later when we get to GraphQL, you get to see in details what we're talking about. Then you have an ER model database, which is more of an entity relationship. So if you're familiar with working with a relational database, you might be familiar with the term entity relationship, ER. And databases like this, they are more specifically suited to the relationship between data and how it's set up. Then you have documents databases, and some of cut across, like obviously the cut across place, you are seeing NoSQL across. So document databases are databases that are more of like the store or the store, so their data in more of a document format. SQL. Okay, so NoSQL databases. This is by saying NoSQL, you need to understand the word what SQL is. Okay, so you need to understand what SQL is and how it works before you then say NoSQL. So in terms of NoSQL, we have document databases like MongoDB. Databases too, like your GraphQL and some other ones. So some of these relationships or some of these descriptions we cut across. So we'll just be looking at two key or the two major database types of classes. What are the key considerations in a database management system? One of the challenges I've faced a number of times as a developer is I want to work on a project and I'm asked what database do I want to use. And sometimes you just want to jump straight to say, oh, well, let's go and use MongoDB because maybe you've experienced the ease, maybe you're more familiar with that language, maybe you're more familiar with what there's this temptation to want to jump with, but sometimes there are some merits that some have which another database may lack. It might be some project that may specifically require, or perform better with a certain database type. So you need to put some consideration into things. I remember one of those projects I worked on an insurance company application, and one of the things they kept asking me is why not use SQL, and they kept on mentioning things that you could have from SQL, and most of the things that were their concerns, I realized that those concerns already had a solution for them with NoSQL. So in some of these cases, you might want to consider some of those things. A lot of companies that still use SQL today, most times there are companies that have long started working with those databases, and making the switch is not so easy because you have so much of information, so much of code base that is dependent on those systems, and making that switch is not so easy except to just part and slowly migrate. So there's why a good number of companies are switching over to NoSQL, like MongoDB. A good lot of them companies that deal with so much information like banks. So why or what are the considerations for choosing or selecting a database management system? Now, databases are primarily called relational. NoSQL databases are primarily called non-relational or distributed databases. Now let's look at the language. Okay, let's look at language. The language we have. Okay, the language we have here. We have SQL. Okay, and SQL is basically a structured query language. Now, this SQL databases, they manipulate data based on using SQL. And when we use SQL, for those who might have an experience with working with SQL, we realize that SQL is pretty powerful. Okay, it's very powerful in the sense of querying a database, in the sense of being able to do powerful, it's very versatile, it has so much of applications, so much of ways and complex queries that can be performed using SQL. Now that's not to say that NoSQL doesn't have also such ways of having such complex queries. Some of those queries that I've seen SQL been able to do, been able to match it with what NoSQL can do, and we've seen that a lot of this already it's already functional, okay, in NoSQL. So what are the things you might want to consider? One of the things you might want to consider is that SQL is in some way restrictive. It's restrictive in the sense that you need to use a predefined schema to determine the structure of the data before you work with it. Okay, so I remember one of those projects I was working on, and I was working with a developer who was familiar with SQL but not familiar with MongoDB, and the first thing was I want to see code. I want to see what I want to see the entity relationship and everything, and I was like, come on, this is you don't have to build a table when working with MongoDB. Okay, in NoSQL, you don't have to build the schema or the table or the data structure from the start. As a matter of fact, if you want to start with SQL, you have to spend some good amount of time in preparation, designing what the structure will be like. So you begin to, first of all, you go to the database and start preparing the database before you can then connect to API. So you want to go, you create the table. After creating the table, you begin to define some of the entity relationships. If you are using maybe like entity relationship migrations, then you spend time defining certain parameters like type of parameters that will be coming in and all of that in the schema. And by the time you're done doing all that preparation and everything, if you don't do that, if your schema doesn't quite match what you want to do, then the whole system is disrupted. And if you want to make any change, like you want to make any change in the structure, it's pretty much difficult. Okay, you want to make a change in the structure, it's pretty much difficult because like especially if you're working with things like the entity framework, okay, like you have in .NET. If you have entity framework already set up, you can't easily just go about like like updating. You have to do some migrations again and all that. So it's pretty much restrictive. You have to think and do some significant preparations for you to work with SQL. However, in NoSQL, you have more of a dynamic schema. Okay, you have a dynamic schema. You can update. You can update your schema to to include references to what you want. You can update as you go. So most times, it makes it so easy for me. If I want to, like, I'm still taking my time to understand some concept of, or maybe like the client or the organization has not properly defined what I want to build on the back end. I can start with little information and begin to scale up as as the content or the definition becomes clearer. So NoSQL gives you that flexibility of a dynamic schema, and they are stored in many ways, which can be document oriented, as you have in MongoDB. You have graph-based, which you talk about things like GraphQL. It can be organized. Okay, it can be organized in some other forms, and you have some other types of ways in which data is stored. Like if you've worked with like Firebase, for instance, you work with Firebase, for instance, you see how funny looking Firebase is, like in terms of the ease of working with Firebase, as it works as a backend service, and it also doubles as a database service. And as a matter of fact, they even have a hosting platform. So if you work with Firebase, for example, you see that they are storing information in JSON format, basically as documents. So that's some real good flexibility that you can get with a NoSQL structure. And each document can have its own unique structure. So that's talking about language. Now, another aspect you want to consider is, you want to consider the scalability, which is what I was talking about. You want to consider the scalability. Now, in almost all situations, SQL databases are vertically scalable. And when we talk about vertically scalable, the idea or the concept of vertically scalable is that you can increase the load. Okay, you can increase the load on a single server by increasing, the processing capacity. So you might want to increase things like the RAM. You want to increase things like, the CPU, the processing power. You want to increase things like SSD to give it maybe like, some more powerful, memory space, or how it deals with it. So when we're talking about vertical scalability, we're talking about, increasing the power, increasing the power of the computers that are used for the database. Okay, so for example, if you have maybe like some massive mainframe computer that does something that's powerful, and then if the load or the need or the requirement of the database increases, you need to scale up. You need to start talking about increasing, adding some more memory units, adding some more processing power to it, upgrading the processor capacity. So that's vertical scalability. Okay, so vertical scalability talks about increasing the processing power of a server, okay, of a single server. Now, when we talk about horizontal scalability, this time around, it's not about increasing, power, okay? It's about like dividing, okay? It's more like dividing your, more of like your databases, okay? Or the way the database is working, they are dividing it into parallel, smaller, units. They are dividing it into parallel, smaller units. So you can have multiple servers that are put together as, all these servers have their own different instance of the database you want to work on. So you have more servers. So that concept is what is called sharding. Okay? I think in 2 pages from now, I'm going to explain sharding in details. So when we're talking about horizontal scalability, we're talking about, instead of increasing the processing powers and increasing, the capacity of a single server, we're talking about having multiple. You can have multiple small servers. Okay, adding multiple small servers that will then share the load, which we will look at in terms of load balancing. So they will then share the load. While in this other, in vertical scaling, you have the load is on one single server and it's heavy. You need to increase the capacity. In horizontal scalability, you're talking about sharing the load among multiple servers. Okay, so you're sharing the load among multiple servers, and each one of them, is available. So it's similar to adding more floors to the same building versus adding more buildings to the neighborhood. Okay, so thus NoSQL can ultimately become larger and more powerful, making these databases the preferred choice for large or ever-changing data sets. So that's one of the major reasons why lots of companies that are like real big are considering moving into NoSQL, because they consider the fact that instead of you having to deal with having to start getting supercomputers and massive inputs for you to perform what you want to do, You can decide to share this load among, like more sets. So you can just latch up a new, you can easily add and remove databases, just stack it together as a parallel, a parallel available database that will take on, more of the load, splitting the load among each other. So that's scalability in a nutshell, horizontal and vertical. The next you want to consider is structure. Okay, the structure. Now, SQL databases, they are more of a table-based. Okay, table-based in the sense of you have rows and you have columns. And then on the other hand, NoSQL databases, they are more of like key and value pairs, where you have in objects. Okay, so they're more of key and value pairs. So you have, the key, which is probably the name of the character, and then you have the value, which is what essentially you want to keep. Okay, so NoSQL are more of key or value pairs, while SQL are more of rows and columns. Okay, and you have graph databases, and then you have white column stores. All right, now this makes relational SQL databases a better option for applications that require multi-row transactions, such as an accounting system or for legacy systems that were built for a relational structure. So here now, just like you see now, you're seeing here you have multi-row transactions, and you see that this goes great for accounting systems. So this could be one of the reasons why accounting, platforms like banks and insurance and other companies would consider using SQL. So these are some of the concepts that you might want to understand, or you might want to take time to grasp, because you have industries that have been using these things, and if they have worked and they've had their technical difficulties over the period of years, and they've had their breakthrough solutions also in a period of years, then if they are considering certain things, you want to, first of all, take time to appreciate the fact that yes, they have done their own on the ground studies, their own analysis in so many different ways, cost, benefit, and everything. And if they have chosen that, then when you want to get into a niche or into a particular area or business, then you want to find out what are the underlying softwares. If, for example, I want to build something related to fintech, I will be, considering certain choices. I'll be looking at, okay, what are the choices? Why are most of the companies in this niche using this? And that will help in you, thinking about it. If somebody comes to meet you today and says, okay, I want you to design this, then you want to, first of all, look at it from this overall perspective before you go ahead to say, okay, I'm good with MongoDB, let's use it. Okay, I'm good with SQL, let's use this. No, you want to have an overview of, the performance in these considerations. The next is you have a property followed. Okay, so in terms of SQL databases, they follow some properties. This is the ACID properties, and it would do you good to go check them out at the end of this class. Okay, so when we're talking about atomicity, you want to say that, if you have, for example, a transaction, there are certain transactions that are key components, or certain like functions that are key components of an action, and you want to say that all these actions, for example, must be fulfilled before you can say that this has been done. And if all of them, maybe like out of 5 transactions or queries or things that should happen within a transaction context, if all of this doesn't happen, then you want to do a rollback to make sure that, okay, everything returns back to the way it was before. So there you need to look at concepts like consistency, isolation, and durability. So these are some concepts that you want to look into, okay? And another one is that NoSQL database follows the Brewer's cap theory. And there you have concepts like consistency, availability, and partition and tolerance. And when we're talking about partition, you're looking at the whole idea of horizontal scalability. Then in terms of availability, a way I would like to describe availability is that, let's say, for example, you have 2 or 3 servers, okay, for example, that are horizontal. Now, it's possible that you can have like 2 servers. So let's use 2 for instance. And these two servers, one of them might have a duplicate set of information of the other server. Okay, so server 2 has basically the same information that server 1 has. So at any point in time, if server 1 is down, then server 2 becomes available and becomes the server that performs all the different operations that you need. Okay, and then when server 1 is back up, server 2 now returns to update all the information that it's kept and then continue as a backup server. So you can imagine the experience you have in banking, banking experiences where you hear server is down and transactions cannot, occur or happen and all that and everything. Just think about if such kind of, theory, okay, such kind of theory was available. You have backup, you have things still moving concurrently, regardless of, the load on the server, regardless of, the technical hitches. So it's easy to have a backup. But like you said, there are different trade-offs. As you consider advantages of a concept, you also consider that those concepts also have their own disadvantages. So I would like that you go, to understand this concept better after this class. Then one more aspect to look at is support. Okay. Now, in terms of support, there's great support for all SQL databases from their vendors. They send in like so much of support in terms of information, upgrades, details, and everything. They want you to use their platform. Okay, they want you to use their platform. So obviously, they want to support you in terms of documentation, things that can help you well understand how to work with certain things. For instance, you want to maybe like do some requests, maybe you want to query a database. You have documentations of all those different functionalities as you'll be able to get depending on the database of choice. Now, also there are lots of independent consultations, okay, that can help you with SQL database for a very large scale deployment. But for some NoSQL database, you still have to rely on community support because, to be frank, a good number of NoSQL databases are open source. Okay, they're more of open source. So it's more of a community as opposed to where you have MySQL you have MySQL, you have Microsoft SQLite, and all those ones that are by specific companies, they're owned by specific companies. So those ones, they're more of enterprise solutions, okay? But where you have open source community projects, you rely on community support, and only limited outside experts are available for setting up and helping you to deploy large scale NoSQL deployment. But if you have, like your regular scale deployments and everything, most of the challenges you need are already there in documentations. You find them in different places, Stack Overflow, even the documentation from the different sites. So some examples of SQL databases, you have PostgreSQL, you have SQL, you have Oracle, you have Microsoft SQL Server. And for NoSQL, you have Redis, you have Cassandra, MongoDB, Bigtable, HBase. There are so many. And what I would advise, okay, what I would advise is as a developer, you should know at least two. Okay, you should know at least one of each type. You should know at least one of each type. If you know how to work with SQL, then you should spend time learning how to work with MongoDB. If you know how to work with MongoDB, then you should learn how to work with SQL. And then if you already know how to use the two of them, then you should add an additional one. So maybe you can go for PostgreSQL to see how is it done here, what's done differently. And then if you're already familiar with working with MongoDB, then you want to ask yourself, what's the next big NoSQL database you can use? Let me practice. Let me just, for a testing purpose, try this out to see what it's like, because a lot of times for different jobs, you might realize that maybe some companies will be asking for a particular one. Maybe instead of using MySQL, what they are using is MariaDB or PostgreSQL. So the knowledge that you have can be passed across, okay, between SQL to SQL, and also NoSQL to NoSQL. But in some cases, some of them appear slightly more different. So it's good for you to practice, okay, just for practice purposes. try doing one thing that you implement in one of these ones, try doing the same thing in another type of database and see that you can get it done and you have a plus to yourself. So let's sum up the key differences between SQL and NoSQL. Let's look at the key differences. So one is, okay, we know the title, relational, and the other one's non-relational. And here in SQL, the databases have fixed or static or predefined schema. And then in NoSQL, they have dynamic schema. And you can actually really define schema. You have packages like Mongo that can help you to define to predefine the schema. Okay, so Mongo can help you to predefine your schema relationship. So in case you want your NoSQL to have similar capacities or characteristics of your SQL, you can tag along some additional packages like Mongo to give schema relationship and extra functionalities that you would expect if you're working with an SQL. Now, these databases are not suited for SQL now. They're not suited for hierarchical data storage. Okay, they're not suited for hierarchical data storage. And just like Delight was mentioning, he said you can store an object in an object. Okay, so that's okay. Storing an object in an object is some really, really good advantage of working with NoSQL. So you can have hierarchical data storage. You can have multiple nested information, okay, when you're dealing with NoSQL. As a matter of fact, when working with some projects like NFTs, you have so much of nested information. When working with NFTs, you have so much of nested information, one into another. So that's the beauty of working with NoSQL. You can have hierarchical data storage, or when working with SQL, you have to start doing a lot of mapping the relationship of one data to the other, and it becomes the setup of the table becomes a lot more complex and confusing. Okay, so you have so much foreign keys, you have so much of everything. So you see some advantage of working with SQL as opposed to working with SQL. And then here, talking about SQL, these databases are best suited for complex queries. Okay, so you've heard it, they said it, they are best suited for complex queries. So when dealing with things like accounting softwares, you have so much of complex queries that you might want to do. You want to tag along so many different queries. For example, you want to get so much information. You want to check things like how many of employees are in this company. Okay, among the employees that are in this company, how many of them have salaries above 100? So all those complex queries, you begin to tag this, tag that, tag that. By the time you've done that, you realize that you have so much of complex queries together, and SQL is best suited for that. So systems like Facebook, for instance, I believe I can't remember, but they use more of SQL because there's so much of relationship. You can imagine how there's so much of interconnected relationship on systems like Facebook. You want to link all the people that are your friends. You want to link all the friends that are your friends as friends of friends. You want to then have maybe groups of the groups you belong to, maybe you're on this group, maybe you're in this community, so there's so much of complex relationships on such kind of platforms. So SQL will do very great for such kind of platforms. So for Facebook and Twitter, yes, thank you. For Facebook and Twitter, you have more of SQL. And then, for simple applications that have to do with just your regular create, read, delete, and all that, you can then use things like NoSQL and do very great in handling that, and can give you some really good performance in that regard. Then talking about SQL is vertically scalable, and when I explained vertical scalability, I talked about increasing the processing power. You want to increase the memory, you want to increase the processing power when you're talking about scalability. So you have like a server that has a single load, a single heavy load on it. You want to increase the processing power for it to do more. And then when you're talking about horizontal scalability, you're talking about having like, several servers in parallel that, the load is shared among them with something you can call a load balancer that will share the load, among them equally. So at every point in time, if one server is down, the other ones make up for it. And then you've seen the processes, you've seen the theories that they follow. One follows ACID, the other one follows CAP. So you can check the two of them out and get better understanding of the CAP and the ACID theories. All right, now going forward, let's focus on the core of what we'll be using, because we're looking at working on the main stack. And though I will not be teaching you guys React in the process of this class, you have the chance of actually learning React. We have mentors and facilitators, trainers taking React on our YouTube channel. So if you want to just quickly tag along, just a little basic knowledge of that, you can actually just do that on the side. And as you're working on the back end, you can then just add a little bit of front end to what it is you do. So if you're able to do that, then fine, you've learned the main full stack, but it might not be as easy as you think. So if you find it difficult to tag along that, you don't have so much experience with this aspect, then you want to just focus on this and get it straight. And after the period of this program, you can then learn that and add that to your skill set. So what is MongoDB? So MongoDB is a document-oriented NoSQL database, and it is used for high-volume data storage. Okay, it's used for high-volume data storage, and as opposed to tables and rows, it deals with more of documents. Okay, it uses documents and uses collections. So you will have more of your collections. Okay, so in the place of tables, you have collections. In the place of rows, you have documents, and I'm going to break that concept out soon. Now, documents consist of key value pairs, okay, which are the basic unit of data in MongoDB. So the basic unit of every data in MongoDB is a key and a value. So what is this key? What is the value that is stored in it? Then you have collections. So collections are, okay, like a set of documents and functions which are equivalent to what you have as your table. So your table in your relational database is the same thing as what a collection would do in your NoSQL database, in your MongoDB database to be particular. So MongoDB came into the light in the mid-2000s, and since then it's taken on white space. Lots of institutions are beginning to turn towards it, and it's becoming a good alternative to traditional relational databases. So it's becoming a good alternative. It's working, it's performant, and yeah, so that's that. So now I said I was going to talk about horizontal scalability a little bit in detail, because this is the key advantage. Okay, this is one of the key advantages of working with a NoSQL database. So you should properly understand this concept so that you can make good use of the advantage. So when we're talking about a database shard, or simply a shard, it's just like a partition of data in a database or search engine. So it's a partition, and each one of these partitions, they are held on like a separate server instance. Okay, so it's just like a partition, and each one of these is on a database server instance. That's like the way in which the load is spread. And let's look at it this way now. Some data within a database remains present in all shards. So there may be some data like maybe the individuals, like ID. Okay, so such kind of information you want to store within across all databases. Okay, so then things like maybe collections that are belonging to an individual, you can then split them. Okay, so you can split them. Maybe this database handles collections, that database handles this handles this particular collection, so maybe that handles another one. So probably like if you have something like maybe like a sales transaction, okay, like a supermarket. So you can have maybe one collection dealing with things about employee information. You can have another collection dealing with things about, the purchases per day. Then you can have one that deals with like just storing transaction history. So it doesn't store in all the information, but just like a log of all the transactions that happen. So all of these could be split into different, like instances and spread all around. Okay, so each one of them acts as a single source for the subset of the data. Now, when we say horizontal partitioning, the idea here is that rather than you having it being split into columns, okay, rather than you having it being split into columns, what you are doing is you are more of like holding all this information separately, So that's just the general idea of partitioning, okay, and one of the advantages, of this is that you can have this distributed over multiple servers, okay, and the total number of rows in each table it becomes reduced. So instead of you having like if you are dealing with a table now, if you're dealing with a table in conventional relational database, you can have so many different rows, okay? You have so many different rows consisting of what information will be there, and then you can also have so many different column setups and everything. But this, takes that away, and it, as such, reduces the index size. Okay, reduces the index size, and this more of like a performance boost. So just take your time, okay, after this class, go into it in details, check this knowledge, let it sink in. Okay, that's why you have the opportunity of like this material so that you can always go over it in case there's something you want to understand better. You can see the general idea here, and you can research more if you so choose. So what are the key features of MongoDB? What are the key features of MongoDB? Now, each database contains collections, which in turn contains documents. So each database contains collections, which in turn contains documents. And each document can be different with a varying number of fields. Okay, so each one of them can be different with a varying number of fields. The size and content of each document can be different from each other. So that's one aspect of working with MongoDB. Okay, so you can have like different varying sites. So it's not that everything must be equal because you have this number of rows, maybe like how it is in SQL, because you have this number of rows. You must have all of them must be filled. You have to exclusively, specify in what case any part will be null. You have to exclusively specify, unless you're gonna have an issue somewhere. Then talking about the document structure, it's more in line with how developers construct their classes and objects, respective to programming languages. So we've looked at objects, and when you look at objects in terms of how they are developed, in terms of classes or in terms of objects, your document is basically an object. Okay, JSON. Okay, JSON is just JavaScript object notation. And when you look at it now, object. Okay, so it looks more like what you actually have, a key and value pair in objects, as opposed to it being a row and a column. Then another is the rows, okay, or documents as called in MongoDB, doesn't need to have a schema defined beforehand. So the fields can be created on the fly. You don't need to define a schema. If the schema is not available to create one, so like I said, it's dynamic. However, you could also still have a schema predefined. So it depends on your own setup. Now, the data model available with MongoDB allows you to present represent hierarchical relationships. So you can store an array, you can store an object, you can store complex structures. But when working with SQL, you can't easily do that. You can't have that kind of hierarchical relationship. You can't have like a list in, you can't have like a list on an array in an object. So those kind of setups are not things that you can easily or readily have in SQL database. But yes, you can have this here in MongoDB. So it makes it a whole lot easier to work with hierarchical relationships. Then scalability, we've talked about that. So here's what it says here. It says companies across the world have defined clusters, with some of them running 100+ nodes with around millions of documents within a database. So you can imagine now that you have like 100 million nodes in terms of like how many servers spread across, okay? So you're having like 100+ of that, and all of these are working horizontally. That's how far you can scale. That's how easy it is to scale up, in terms of working with MongoDB. So let's look at an example of an object. Some of us have said we're not quite familiar with MongoDB, so let's start by clarifying an example of an object in MongoDB, or how the document is. As we've been talking about documents, how is it like? So this basically here is a document. Okay, so this basically is a document. All of this here was classified as a document. So don't think of a document conceptually as a file. Okay, don't think of it conceptually as a file. Think of it as this information here. It's called a document. So you can have here, like we have here, we have the object ID, and this object ID here is basically what is used in defining the key. Okay, so this is like the key of this object. Okay, so this is like the key, the special key of this object. And then here we have maybe like fields, and here we can have nested fields. So we can have an information, can embed some information in another into it. So you can actually store an object in an object, and it goes fine. So here, this would be just a simplistic example of it here. You can store in parameters like the key and the value, 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 the key and the value. So all of that you can see that in practical terms. So what are the key components of the MongoDB architecture? For every like every document you have, you need to have the ID. Okay, every document should have an ID. So this is more of the reference. This is a required field in every MongoDB file, and represents a unique value in the MongoDB document. And this is the primary key. Okay, so it's the primary key, and you cannot create a document without the ID field. So this is the unique identifier of every document. Okay, so like you see here, what you have here is different from what you have here. So this is a unique identifier. There's no two IDs that are the same. As a matter of fact, they even try to have that no two object IDs worldwide are the same. So that's why you have as much as 24. This is about 24 characters here. About 24 characters here. So as much as possible, they're trying to have no two object IDs worldwide should be the same. As opposed to when you are working with maybe like using an ID like 1, using an ID like 2. By the time you're using an ID like 1 or 2, like you have in tables, at some point there might be some conflict or confusion when you are specifying one is to what field, one is to what particular row or column. But when you have object ID, an object ID is unique and you can easily trace it in every collection that you search for it. Okay, so here, this is just an example of just a simplistic collection here. And you can see here, these are object IDs, and they're all meant to be different. Why are they all the same? Okay, they are different. Okay, 8. I was wondering why they're all the same. Okay, so here you have example of information that you can have in that. Then the next we'll talk about is the collection. The collection is the grouping of MongoDB documents, and it's what you call your table. So for example, if I was to create like like a table of users, for example, I want to create maybe like a login. When we users register, I want to store their information so they can log in, put in their password and everything. That collection or that table, we call it users, for example, and it's a collection of all user information so that you put there. Now, you could have also another collection related to what maybe it's a blog, for example. So let's say each user is entitled to being able to have their own blog on your platform where they post things, okay? Where they post what it is they want to post, like they have their own page on your platform. Now, you could decide to have a unique or a separate collection for their posts. And then in that collection, all you need to do now is when you want to create a post for any user, you just add in the user's ID. So that collection is completely unique. Here, you don't have all the information about the user there. All you just have is just a reference to the user's ID. So whenever the user creates a post, the ID is tagged along to that post, and you can use it in querying the database for all posts that belong to that user. So you can then render that on the page. So the collection is basically, just doing the same thing as what the table will do. Okay. Then we have the cursor, which is more of like a pointer to the results. Okay, result set of a query. So we'll see that when we get into practical terms. Okay, we'll see that when we get into practical terms in our next class. So we're going to work with like pointers. We're going to have pointers and the kind of queries that come with them, like insert one, async, like delete one, different query parameters that are available on MongoDB. Then you have a database. So a database is a collection, is a container for collections. Okay, so a database is basically a container for collections, just like you have in your relational database management systems. You have this time, your database is a collection of all your, it's a container of all your collections. So you can set up a project, and as you create a database name, you can call the name of the project that you're working on, and then all the collections in it could have their own unique name as so choose. Okay, so a server can store multiple databases. So a server can store multiple databases, whether it is your local server, as we'll install next class, or whether it is your online MongoDB Atlas, as we'd also be working with in our next class. You can store multiple databases on them. Then we have documents. Okay, so as we've said, a document is just a record. It's just like the simplest unit of information, and it's more of like your information that you are storing in a collection. Okay, so the information you store in the collection is basically documents, and it consists of the key and value pairs, or the field name as you call them. And the field name is a name value pair, okay, in the document object. And then let's go straight into Bison. Okay, so what is Bison? Now, I was asked this question. A while ago in one of these interviews I've had. They asked me out of the blue, what is the difference between Bison and JSON? And while I knew it very well, it was just funny that I never would have expected such kind of questions to come up. Okay, but it's good to take time to understand the thorough working of what it is you work with. So generally, when we talk about Bison, we're talking about binary encoded JavaScript object notation. Okay, or now when we talk of this here, it is like we talked about how a class can inherit from another class. Okay, you have a class can inherit from another class, and when a class inherits from another class, it takes on the properties of the super class. Okay, it takes on the properties of the parent class, and then you can tag along some extra features or some extra functionalities to it. So the Bison here now is more of an extension of the JSON model, and the purpose of this extension is to add or provide additional data types that you cannot find in JSON, in JavaScript object notation. So additional data types will be data types like dates, okay, the date data type, and binary, and some other types of data types that are not readily available in JSON. That's what by extension they have been able to add to Bison, and it's also efficient for encoding and decoding with different languages. Okay, so they have something like a serialization method, and that's something I don't think I need to explain that for that class. But here, this is the core of what Bison is. So MongoDB basically stores information under the hood in Bison form. Okay, so it's more of Bison rather than JSON. So it stores information under the hood in Bison form. And yeah, so that's that. So before I go, I want to take a pause just to find out if anybody has any question thus far. Okay, if anybody has any question thus far, I'd like you to raise your hand. Okay, if you have any questions thus far, I'd like you to raise your hand. Okay, if there's none, you just put a thumbs up so I continue. I just want to be sure everybody's carried along. If there's none, you just drop the thumbs up in the chat or via the controls so I can continue. All right, so what are the key considerations you have with working with MongoDB, okay, when modeling data? So one of the things you look at is what are the needs of the application? What are the needs of the application? So that would tell how you're going to model the data. So oftentimes, one of the first things we want to do is we want to understand the needs of the application, have an idea, discuss well with the project management team, okay, people who have like a clear description of what the application should do. Okay, so you want to understand it, and then based on that, ensure that what you have here, you can have some form of like structure of it, like this is what it should look like, or this is what you want to do. So where you need to have like a schema relationship set up, you need to also do that. Then the next is you want to also ask like, what are data retrieval patterns? So if you realize that you're going to have heavy query usage, then you need to consider some other options. Okay, so here we're seeing the use of indexes in your data model to improve the efficiency. Into like when we get into working with create, read, update methods and everything, we'll consider what indexes are and how they can improve queries. Then we want to ask, are they frequent inserts and updates and removals happening in the database? Okay, so if this and such is happening, then you should consider the use of indexes. You should incorporate sharding. Okay, so that's the part we talk about partitioning, and all of these things have to be things you put into consideration because this will determine how you write your code. Okay, this will determine how you write your code, how you do your setup. So why use MongoDB? We've talked about it as being document oriented, and we've seen the advantage of its flexibility in terms of how you can have data in so many formats. You can have it in hierarchical format. You can have it as, you can also use schemas. So there's a flexibility to how it can be adapted. And, since it looks closer to the object codes in object-oriented programming, it makes it a lot more easier to, you can just store an object directly instead of you having to have different ways in which you store information. You could just go straight to store an object directly. Then you have queries, okay? So it supports queries. You can support query. You can actually use regular expressions, regex, and all that. And then indexing, replication. And the replication is what I talked about before, where you can have like a secondary replica, maintain a copy of the data. Then load balancing is the concept we talked about, horizontal scalability. So this is just for reference purposes for you to understand. So what would be the differences between the two of them? Between what do you have between relational database that is different in MongoDB? So relational, you have it called a table. In MongoDB, you have it called a collection, and they're basically just one and the same in terms of the functionality, but in how they are structured, they are differently. So you have maybe like a row and column in a table, but in collections, you have more key and value pairs. Then talking about rows, we have rows. So they're called rows, but so a document is like a single, represents a single aspect, okay? A single aspect of the information that is you want to store in terms of like that's what you call a document. And then your column and fields, okay, you have your data values, and then you have like things, you have joins and embedded documents. So in embedded documents, it's just the same way you can like have like your documents stored in separate different collections, but you can then embed them using your object tag and everything. So I think that's that. Okay, I think that's that for the theory part of what we have for today. So let's look at installing. Let's look at installing MongoDB. Okay, so let's look at installing MongoDB. Let me go to share my browser window. All right. Okay, so I would like to ask. Okay, I would like to ask at this point, if you have MongoDB stored on your local computer, just for reference purposes, if you have MongoDB stored on your local computer, could you put your hands up, so, or at least I'll have an idea of those who already have it set up. Okay, if you have MongoDB stored on your local computer, could you just put your hands up? Anybody, you have MongoDB stored on your local computer? Okay. I'm not seeing any hands up. All right. If you have Compass, set up on your system, could you put your hands up? You have Compass from MongoDB. Do you have that? Anybody? Yeah. Okay. It doesn't look like anybody has Compass set up. Okay, so let me see. How do we install that Mongo? Okay, sorry. How do you confirm that MongoDB is installed? Okay. Is there a command to run? Okay, all right. Okay, all right. So yes, anybody else? I'll attend to that question. Anybody else? Anybody have MongoDB's Compass? Okay. Nobody. All right. Okay, so generally these are like things that you can always like search online. Okay, these are things you can always search online. There's no, okay. Most of you use cloud-based MongoDB. All right, that's Atlas. Okay. All right. Okay. So all right. So we're going to go through the installation process, and after that, we're going to go through the installation process, and after that, we'll look at different queries you can query. Okay. All right. All right. So So here, can't remember the endpoint now. Let me just type download. Okay, let me just type download MongoDB. Or I think we should start first of all with Atlas. Let's start first of all with setting up Atlas. Let's start with Atlas because that looks a whole lot more easier. So you can go to cloud.mongodb.com for those who want to use the Atlas platform. You can go to cloud.mongodb.com, and when you do that, okay, when you do that, you can sign up. Okay, you can sign up either by this. Okay, so either you go here to log in with a Google account, or you can create an email address. I'm speaking for those who will be watching later on by video. Okay, so you can do this and everything. So let's say you want to sign up as a new user. You go straight to create your account. Here you can put in your name. You can put in your name and all that and everything, job function. And after doing that, you click on the sign up. So I'm clicking on the sign up. Do I have any reason to open a new account? No, not really. But let me just do this. Okay, so let's say I have this, and here let me just put this here, and let me just put this here now, and here. So and password. Oh god, do I really know any strong password now? Okay. Okay, I'm not sure when I remember what I typed there, but yeah. So okay, password is strong, at least 8 characters. Phone number. Okay, well, do I have to? Okay, all right. The company name, and then job function. I think I'm tired already. Okay, it's job function, software developer, and okay, let me just put my company here. So let's put here soft technologies, and with a T, capital T, and okay, all right then. Here country, obviously Nigeria. Okay, let's go. I don't know how to spell this thing. This used to be like an easy setup. Okay, so Nigeria, and read the policies. Okay, you just go ahead and read it. Okay, and then sign up. All right, so signing up here, just so they don't send me a confirmation email, because at that point I will not be following. All right, great. Send me a confirmation email, which I don't have strength to sign up. Okay, so at least from this point here, you know what to do. Go to the confirmation email, and let me just go back to logging in. So when you log in, generally for a starter, let me just go over. Let me just go over. Let me just go over the process to see if they will allow me to create another free account setup. So here, let me just put in my order. All right, so here I sign in here. Password, please remember my password. Good, great. All right, so logging in here. Here you can it's taking some time. Okay, so here you can have like what we call a cluster, but this really won't be the process you will start off with. Okay, this really will not be the process you will start off with. If you want to start up with the process, you need to, or let me just confirm that email so I can lead you through. Let me just confirm the email on my mobile phone, so I can lead you through like the whole process of creating a cluster, because sometimes you can make a mistake in that. So let me just do that confirmation here on my mobile device, because I don't have my email set up. Okay, so yeah, okay. You just give me a second. Doing the confirmation here. All right. Great. All right, confirmed. All right, so let me go back and log in again. Let me go back and log in again from here, and let me use this new or here. Okay, so yahoo.com, and if I still remember that password. Seriously, like, I was not. Oh, come on, coming. Let me clear this off. Log out, please. Okay. Okay, let me go again. All right. No. Oh, all right. Oh, finally. Thank you. So, if you noticed, we're doing like a process. I think they were trying to confirm if my email does exist on their platform, and I didn't seem to have saved that. So, okay, so let me just do this. Yeah, can I remember the password I just wrote? Okay, let me just copy this just in case. Oh man, seriously. Okay, okay. Oh god. All right. I thought as much. And now after all that now, they still didn't. Oh god. Oh god. I should have just used a password I remember. All right. So hope this works now. Oh god. I didn't use a password I remember. Okay, I'm going to never. I thought I actually like used the password I remember. She just gave me like a second. I don't know why. I don't know why it didn't save. I thought I did save the password here in my password manager, but it looks like it didn't save there. So next time I'll just use a simple password I can remember. None of this works, none of this works. None of this works. God. No, this looks okay. Let me just try one more time. If it doesn't work, then I'll just go and try and do it directly from here. Or let me see. Okay. Let me just do one more time. If it doesn't work, then I'll just try and do it from another. Okay, it doesn't work. Let me do it directly from the other ones. Okay, so just let me do it directly from here. Let me just use this and I'll go over the process of doing it here. So I'll just go over the process here, trying to see if I could start another cluster. Um, so normally when you sign in, okay, when you sign in, or you log in the first time, one of the things that they want to show you is to show you a point where you have to create a cluster. So there's the cluster part that I wanted to show you by starting at first, but I just think I was so much in a hurry that I didn't even take time to remember my password, and I'm not ready to open up my email just yet. Okay, so all right, so let me see if I can simulate it. Okay, so here or here, let's see. Okay, so generally, this is the first page that you would see. Okay, when you go through that process, this is the first page that you would see. So here you will see you have here, this is called serverless. Okay, and let's just have a preview. Now it says for serverless applications with variable or infrequent traffic, variable or infrequent, not much. Minimal configuration required. Resources scale seamlessly to meet your workload and pay only for the operations you run. And it has pricing. So this is serverless, and here, that's it. Then we have dedicated. Okay, so dedicated now working applications with sophisticated workload requirements, advanced configuration, like sophisticated on the back end, like want to use dedicated. Then you have shared. Is for learning and exploring MongoDB in a sandbox. You want to use the shared for a start. And here you have like 3 different providers. Any of the 3 you want to use, they are available. Then here, this is just about like the region in which the site, like the database is being hosted. So any of them is okay. If you want to choose US, Oregon, any one of them is okay. It depends on your traffic flow. I want to consider that. I don't want to consider that. You can check advanced opinions on this. There's not much of a deal. Then here, this is the cluster when you want to create a cluster. So here in creating a cluster, you have here like cluster prices, okay. You have additional information you want. If you want to turn up backup, you have a cluster name 01. So here you click to create cluster, and it should create a cluster if you are doing it the first. You have one free cluster, okay? You have one free cluster per time. So that free cluster is something in which you can test that. So this is just like the process. So I don't have all this, you should just create, just click the create free cluster. So basically just choose the default that you have there, choose the shared, then choose the other defaults that you see. Everything is good from there. Then you create cluster, and it leaves you here. So I already have a free cluster which I've been using for my testing development purposes. So, or that's why I can't create one now. So just go straight, and that will work for you. That will work for you. Okay, so yeah, so this is a cluster. So when looking at MongoDB, you have like certain keys here. Okay, you have like certain keys here. So let's look at what we have here. We have here basically the project name you call. Okay, so basically the project name you call, you can decide to have new project or such. If you're ready to pay for it, then you have the database itself. Okay, so here database here will involve the clusters you have. You can browse collections, which basically are like all the information that all the information of clusters you have. Then here we have data lake. We haven't really much used that. Okay, so I haven't really much used that here. Then triggers, you might not really need to use that either for this level. Okay, so these things are things that you don't really need here for this level. Then you have database access. Okay, so database access is where you can have like you can create users that you want to be able to access a database that you create, and then you can give them different levels of rows. So you can create different levels of rows. So if you want to do that, you can create rows. So here, how do you want to access the authentication method? Is it by password? Is it by certificate? Or is it by official AWS setup? So if you choose password, then you can create the username you so choose, and then the password that you want, or you can do an auto-generate password and to generate an auto password if you want. Okay, so just as you see, auto-generated password, and you can copy that and keep it somewhere if you want. Then here you can choose the privileges that you want that user to have. So in case you're working with multiple people on a project and you want them to have their own unique access to a database that you are managing. Okay, so you want to maybe choose, okay, the person has only read, so the person can only read on the database, but the person cannot create or update or delete anything, but can only read information there. That's one. Then you have like Atlas admin, so the person can delete other users and all those additional information and Atlas admin should have. Then you have the read and write access, which should be there for fellow developers working with you on the project. Then you have things that you want to do. You can restrict access to specific clusters. So you can choose that, okay, I want this person to be able to work only on this cluster, but that's for advanced for now. You have only one cluster available. You can also decide that you want this person to be a temporary user. So you can set how long the person can access it. So in the instance where you have like you're sharing, database with people for some time. Okay, you might want to do that just to give them temporary access. And there you create your user. Okay, network access, you might not need that. But in network access, one of the things you want to consider is the IP address. Okay, there's a default IP address of 00, which means that you can from anywhere, okay, from any IP address. Also decide to choose a default IP address. Okay, so you can add your current IP address, which will include your location. So anybody trying to access, from a different IP address will not be able to access that. So that's like an extra security protocol, just in case. For general purposes, okay, for testing purposes, you just want to keep everything so you can access from anywhere you want. So that's just the basic of the console. So let's look at when we have our database setup. So let's look at when we have our database setup. Two things you want to do is you want to be able to connect your database to your local, to your VS Code where you're doing your work. So here you have like 3 ways you can do your setup, which we will see in our next class in practical terms. So our next class, we'll just be starting with practical, installing, and I think I'll just share a link for installing, okay, to help you, like workflow guide. So we have installing, and then go straight into CRUD operations. So on Friday, don't miss it. We'll be going over CRUD operations on Friday, using MongoDB, the setup, and all those queries. So here you have, if you want to connect with your MongoDB shell. Now, MongoDB shell is basically what you have running on your command prompt. Okay, so what you have running on your command prompt, the part that runs in like the shell. As we will see when we have a local version of it, then you use this. Okay, you use this if you want to connect to your local shell for that. So this will be the correction string. So here you can say here I have Mongo shell installed, and when you have Mongo shell installed, you can then use this connection link in your application. Okay, now that's one of those methods. Okay, let me go back. The next is you want to connect to your application. Okay, so you want to connect to your application, and in your application this time around, now when you are dealing in the shell, basically the different processes that you want to do, you are doing them via command prompts. Okay, so you're doing them via command prompt, and this is like unnecessarily hardcore. So I don't think I need to explain this. Maybe we'll just do like 1 or 2 commands just for example purposes in our next class. But come on, like when you're building an application, what's the stress of like doing everything hardcore in the shell? So then while in your application, what you are doing here is you want to set this connection up in your app. So where you have like your VS Code running, and then you want to set up your connection, there you can do that. Okay, so if you want to do that in index.js, or you want to do that elsewhere, that's where you can do this. So we'll do this also in practical terms too. Okay, then DB compass. Okay, so that's for disconnecting MongoDB compass. And let me share my screen. Okay, so let me just share my entire screen. So I'll show you what that is like. So for those of you who have been working with reaching directly to compass, I would advise that you should try to have class, and I'll give you some of my reasons, okay? When you want to access this page, for instance, this, okay, you can see here in this page that some of these things are taking time to load. I'm moving to database, and you see it's taking time to re-render. You see it's taking time to re-render. Okay, I'm getting a low system resources error. So you can see now it's taking time to. Okay, I'm back. Sorry about that. Zoom crashed. Okay, so sorry about that. I'm back. All right. Where was I? I'll share my screen, and before Zoom crashed, so I'll come back. All right. Prosper, can you hear me? Hello. Can anybody hear me?
Yes.
Yeah, I can hear you.
Okay. All right, thank you. All right, okay, great. All right, so what I was saying here is like when you move from the page to page, it takes time and a lot of data to like render each theme you want to move here. Okay, so if I want to browse collections now, it roughly would start downloading like content in that page. But basically, why a mobile application is faster, okay? What makes a mobile application faster is that some of the things that you would already lumped up together in the app. So things like pictures, things like icons, things like like beginning text and everything. So if you want to then continue, if you want to then continue, like maybe you want to move from page to page. Imagine now that I want to reach out to MongoDB now, Atlas from this local machine. What it is going to do is it's basically just going to be picking only the document informations, like things like just like a few kilobytes of data, which basically just like very little JSON format or Bison format. Okay, so generally this will make it a lot faster in terms of approach. What can I use? Which one can I use? Which one can I use? Which one can I use? They all look the same. Okay, let me use this one. This one's a project that it basically doesn't have anything in there. Doesn't have anything in there. Part of the application. I just don't have anything in there. I'm not set up on localhost. Okay, which one barely has anything in there? Okay, this one barely has anything in there too. Okay. Okay, so yeah, so once that connection is done here, we're able to query things. So at this point here, once like things are done here, you'll be able to access like things that are there with easy click. Okay, if there's some information here, you'll be able to access them with easy click. So this is it makes it like pretty fast in getting things. Okay, so you can quickly right now I don't really have anything in this place here, so it makes it like pretty easy or pretty fast in being able to retrieve or get things here. So this is more like where I did my testings and everything, so barely have anything here either. But you see now that like just within a click, okay, just within a click, if you want to check something, instead of you having to, go through the stress of waiting for your, go through the stress of waiting for the system to, start downloading. If you have poor network speed and everything, you just want to download just the little bit of information that you need to get things running, and that's fine. That's great. Okay, so that's fine. That's great. So I would advise having Compass on your local machine for the purpose of easily checking the database for what you want to see. I would advise that you have Compass there and everything. So that sums up. Okay, so that sums up the general setup of that and everything. So here, from that point, in our next class, we're looking at connecting with these three different methods. We'll download the MongoDB shell and we'll connect to it on a local computer, and then we'll see how to start up the setup and how to keep the setup running. The process of doing that, and then we could also be able to see the contents that we want. So as opposed to the way you want to see content using the MongoDB shell, it's like a command line interface setup, and the querying is not as easy as you think. Okay, so except like people who just want to spend time learning the query for the fun of it, you can easily just check what you want on Atlas or check what you want on Compass. And Compass allows you to be able to connect to both your local database or the Atlas database, so your cloud database, both of them. Compass allows you to do both of them. Then here, this is what you use in connecting your application string. So I think that's the much we can look at for today. That's the much we can look at for today. So I'll take questions. And in our next class, we'll go into the nitty-gritty of CRUD operations using MongoDB and installing, and then I will introduce Mongoose. Okay, I'm going to introduce Mongoose in our next class also. So what we can use Mongoose to do, and we should have some practical solutions that we should be able to try out using the CRUD operations. So yeah, so that's that. So I'll take questions. Any question from me? If you have questions, you can put your hands up. If there are any questions, you can put your hands up. Okay, I have one person. Yes, any other person, if you have questions, you can put your hands up. Any other person? Okay, I have one here. Okay, yeah, Delight, your question.
My question is about the cluster on the MongoDB Atlas. Is a cluster within a database, or a database is within a cluster?
Okay, a database is within a cluster. A database is within a cluster. A cluster is more like, how do I put it now? It's more like, consider a cluster like the server that they have given to you. A database is hosted on a server. Okay, a database is hosted on a server. So consider the cluster as the server that they have apportioned, that is given to you, and you have like your physical space in any of those countries that you saw on those locations. So when we were trying to create the cluster, they said the cluster was going to be in any of those places. You see West Virginia, you see Australia and everything. So consider that you have like a physical server, and a portion of it is given to you as where you can host your databases. So that's a cluster. Yeah, great. A cluster is a group of databases. Yeah, thanks, Prosper. Yeah, so that's it. So cluster, just as you said, it's a group of databases, and it's more of your own physical apportionment of where it is. So you have like a cloud storage platform on Atlas, and your cloud storage platform on whichever one of it, if it's Amazon or if it's Azure, or if it is Google Cloud. a portion of whatever part of it of the server base is given to you, and that's your cluster. And then you can then have all your databases in there. Your database, each one now has collections. So your database is a group of collections, and then your collections now will be a group of documents, and that's how it flows. Okay. All right. Any other question? All right. Any other question? Okay. So let me just share this as closing remarks. So what you can do, okay, what you can do is you can try to do the download process on your own, just so you can familiarize yourself with it before next class. So if you want to download MongoDB, just type download, okay, just type download. And what you'll be downloading, if you want to install the MongoDB, is the community version. Okay, so it's the community version that you can download. That's free. So just do that, and you lead it to that page. Okay, this is Atlas. No, okay, this is MongoDB community download. This is if you want to have the local version of it. And once you go there, you see, you see that you can have it locally installed on your device, and you see here a download option. Okay, so in case you just want to share, so I could as well just send you this link in the chat section in case you want. Okay, so as well send you this link in the chat section in case you want. So you could just give that a try, see how it goes. It also has a guideline of how you can go about this. So I would actually like that you try working with the local version. Okay. Just for understanding, because by the time you move into things like DevOps, you would have to learn language of interacting with databases that are stored in such kind of formats. So there's a way you can interact with them. So when you move to DevOps, you'll be talking to databases. Okay, so that's more of an advanced concept, but it's good that at least you just familiarize yourself with speaking to a database using their own query language, which is more of like a shell. Okay, talking to it in a command line for the shell. Okay, so all right. So I think that's much for the class. If there are any more questions, I'd like to call on our mentor, Mr. Prosper, so he can address us, and if there are any information that he needs to share, he could also share. Okay, someone's asking about Compass. There's not much time. I'd like to wrap up this class. We'll be looking first at, okay, the first set of things we'll be looking at on Friday is how to install Compass, how to install Compass, and how to install MongoDB locally. We've already looked into how to set it up on the class platform. So look at those two ways on Friday. Okay, so Mr. Prosper, over to you.
Yeah, so thanks again for the class and all. Yeah, guys, it's been another wonderful session, right? And I think we did better today. We all came early, right? So the thing is about tax. Please take tax and deadlines very serious, right? So that we don't drag ourselves backward. Right, so if you're given a task and there's a deadline, please try and attend to it as at when due, right? We understand that there's a very serious power problem in the whole country now, right? But then, yeah, we should, try and just be up and doing. There's always a way around things. There's always a barbing salon around you or a vet Niger shop. Those people, they must find a way to get lights 24/7, right? So that's some basic workarounds. I'm just giving you tips, right? Or you could go to a restaurant just so you get tax done. We can't keep living on excuses, right? Because if you want to give excuses, there are a lot of excuses to give, and then at the end of the day, you'll find that we're getting things done. Moyo, you said you've not been promoted to stage 2.
Yeah,
okay.
Sorry, I'm actually Moscow Tech. I'm still the one. I'm using my phone this time, sorry. So I'm actually still Moscow Tech.
Oh, okay. You've not been promoted to stage 2.
Yeah.
Oh, okay. Yeah, I'll look into that. No, all right, guys. Enjoy the rest of your day, yeah, and keep practicing. All of these things. You can't just get all of them from a 2 hours or 3 hours class. So it's best everybody goes back and do some reading up. Yeah, that's pretty much it for me. Enjoy your evening. Bye, guys.
All right, now, so you guys take care of yourself. We'll see you in our next class on Friday. So any other information we'll share with you through the Slack channel. If you have any questions or further inquiries, you can also reach out to us on the Slack platform. So that'll be the end for today. So see you guys, and yes, we'll look into the promotion aspect. Take care of yourselves. Bye, guys.